very small budget. So you cannot afford like a 4-year survey. You don't have time to really go through a lot of literatures. And this time, in this kind of situations, a very quick assessment from these open data is very, very valuable. So combined with the idea that TBN started to use these GBIF data, these open data, starting at 2018, and also this legal requirement starting at 2017, we see a huge surge of data downloads. So you can see since 2018, the download events are increasing very vastly, 85% annually for the past 4 years. And not only the downloads, the user visits are going even higher, like 86 annually. So you can see, because of this kind of combination, previously, just before that, even when we started doing this, we are not sure if anyone will want to use this kind of database. We are asking everyone, like, we provided this, GBIF have all these wonderful data. Do you know you want to use it? They say, I don't know, you may want to ask someone else. But then we see this. So this is something. So we hope this case can inspire the direction of how to design your local nation's local portal. If anyone in Asia or anyone in other countries that are facing similar things, similar thoughts, you may think about those experience we have. But also on the other side, take chance to look at the developments of new legal requirements in your country. Maybe some new legal requirements, they look harsh, but this is where our biodiversity open data can really hop in. And this is the place where people, policymakers, will believe that, oh, what's happening? So these policymakers and even data providers starts to believe open data is going to make a difference. And they start to support it, they start to put resources in, and they started to open their data. This is all happening in Taiwan in these things. Okay. So, and very importantly, this will also support, this is achieved through this link between global and local by a national node like TDWG. And this is also very important to support both scientific and policy. So I believe not only a local portal is important, the global portal is still important, especially stressing the science part. And science is still the foundation to make people believe this data is reliable. We still have challenges. Okay, so the challenges include citation tracking. First part is like we really don't know what they are using the data for, because we don't have DOI. DOI are expensive, if you know that. But GBIF have DOI, and this is something we are looking what we can do in the future. Another citing challenge is how to trace back to the data providers. In the current mechanisms, people can use it as an open license, but they don't necessarily acknowledge the data providers that far. Even if we want to acknowledge GBIF more, we still have not developed a very good mechanism. And the others are all related to more and more data. For more data, there's more taxonomic coming in. That's a load for a taxonomic database. More data coming in, the infrastructure gets overloaded. That's also a challenge. And we are asking more than occurrence. That's a need for new data model. Luckily, most of these, I think, are being tackled in the GBIF community. So I think this is important, how this tomb layer model should continue. So this is all. And we have a lot of support from these different money givers and also from GBIF, and very important collaborations with our local partners. If you have any questions, please welcome to contact me. Thank you.
And another reminder for the rest of weekday for
PDF 资料。
Okay, so for the next is Jin-Ying also on from Canada. And she will present building a bridge for data sharing. Sorry, yeah. Glad we will have
The next talk is we'll think about how we can do it.
like it's our developer all like thank you. Question for
Yeah, you can read my question in the comments. Okay, so we have the same. It's like we don't really have very strong building parts. What we show is that we saw first that people know that
没有连接头吗？没有连接头吗？
scientists. And then this question will go back. There are more people using this data, and these data are all for the people. And this kind of real world views is
Or maybe you can connect to.
Yes, I am telling him.
So there's actually there are two types of data owners. Why they don't want to open their data. The other one is that they just don't want to open their data. And then the others are like, why do I need to put effort in doing this if I don't see any real outcome?
I'm sorry.
Try to find somewhere.
I don't see that's anything related to me or related to the general public. Then why do I need to do things like that? I have a lot of tons of other things to do. So that's not going to be very persuasive. But what these data are really being used for this ecological check, and these data are being used to stop some very bad intent construction projects. It started to be this data is making a difference. Then they have the innovation. And this will become a very positive sign. More people are open to data. The other people who don't know the data, I don't know data. Why don't you have the same information source? You should also do that.
Kind of here, but
Yeah.
I just got one more question.
I'm thinking about I saw that they keep on the environmental assessment. Yes. So we have kind of thought it's more sophisticated. But there are further steps
Sorry, the computer doesn't, like, there's a problem with the recognition of the computer to the system for that, but we have another computer now to see if that can resolve the problem. I'm sorry.
Hi, was a great talk. I'm Ariana from Financialist. And so I talked a little bit about this throughout and some of the questions, but I always love hearing about how people are engaging the community and actually uploading their data in the first place. Like, have you found certain strategies or ways that work really well for you? Or, yeah, I'm just curious about that. Yeah, like you know, when they're using the portal, is there like a mechanism for it?
Yeah. So actually, when we promote, when people ask me, I was like, how to upload different actions. One is goes with IPT at time, and you want the data to be very please go to IPT. And then the other is actually provided a more simple form of the output. Very simple. Very basic. And then the others we just encourage all of them to upload to all of them. So I think this is a very important part. And
Yeah. Let's welcome Jin.
Hello everyone, my name is Jin-Ying and I'm from Taipei, same as Jerome and Melissa. And I'm happy to share our practical experience in integrating biodiversity data via Taiwan Biodiversity Database Portal. So let me start by next page. By introducing Taiwan Biodiversity Information Alliance, or you can call us TBA, We are a collaborative network of government agency, national parks, museum, research center, and even private companies. We are built from the ground up. All our partners make decisions together. And we are proud to have 60 partners, and the number is still growing. So what is the shared vision of our alliance?
Okay, then let's preview something first. Maybe point it.
Next page.
Next page.
Oh. Oh, that's sorry. So our vision is guided by five. Why?
Let me help you.
Five key missions. The first and the most fundamental is to promote open access to biodiversity data. To achieve this, we launched the Taiwan Biodiversity Database Portal as the central access point for integrated data. Let's take a closer look at what the portal provides. The portal aims to be the most convenient, which means users can search and download data across agency in one place. And each record on our portal can be linked back to the original partner databases. And to be most comprehensive, it integrates both occurrence and collection data, as well as some biodiversity-related documents and educational materials. Crucially, it has a mechanism that allows users to request precise coordinates for sensitive data. So the real challenge is how to make this massive amount of data to be truly integrated and usable. Here I will start with the data integration. So if a partner already has API resources, they can directly follow our TBI API standard and connect to our portal. But if they don't have an API, they can publish their data through GBIF IPT, which is also one of our partners. And from there, the data will be published to GBIF and then integrate to our portal. And we are also planning a way for data that isn't on GBIF yet to be directly published through our portal to GBIF. Our API standard follows Taiwan Biodiversity Data Standard, which is a national level standard first released in 2021. And some government agencies have also started adopting this standard. It is a Darwin code-based schema with extending fields when necessary. And it gives us two benefits: simplify integration at lower cost and guarantee data quality and consistency. So since its initial release in 2021, the new version is now on the way. With our hands-on experience in real application, our data integration working group has had 12 intensive discussions to refine the field rule and ensure clear definition to reduce errors. After the data format is standardized, the next challenge comes up, making sure we are all talking about the same species. So Taiwan Catalog of Life, also known as TAICO, is the most complete and reliable species list in Taiwan. We use TAICO as our taxonomy backbone for our portal, meaning that all scientific names in the portal are aligned with TAICO. And our portal also feeds new names from the occurrence data back to TAICO. and helping to enrich and update Taiko's database. The key process of this, the key part of this process is making sure that name matches correctly across the data sets. So to do this, we maintain a tool called Nomen Match. Nomen Match is a tool that matches all taxonomy levels, such as genus or family, and it also supports Mandarin common names. And it provides matching score to let you compare the result between different names and offers API service as well. And in addition to Taiko, the Nomen Match also offers different taxonomy backbones such as CO and GBIF. So you are very welcome to try it out. After aligning the names, the next step is to handle the sensitive information responsibly. So here, the partner provides the unblurred and original coordinates data and assign the sensitive category for it. And then our portal automatically blurs the coordinates accordingly before the data is released. So this is the category-based system we use. Here are the six categories, from full precision to blurred coordinates, or just showing their district or species name, or even hidden completely. Why we think sensitive category-based system is more flexible than a fixed sensitive species list, because it allows for regional or seasonal adjustment for the same species. For example, a species may only be sensitive during its breeding season, or a species may require protection in one area but not in another. A good example is this cresting minor, which requires protection in Taiwan's main island, but is not currently considered need protected on Cayman Islands. So this example shows why category-based is more flexible, because it can meet the actual needs before we release the data. So how to access the sensitive data? If you are an alliance partner, you can share and freely access to the sensitive data. But if you are from the general public, you must apply first. So you need to provide your personal information, project details, and if you are willing to share your research outcomes. And then the request will be reviewed by data owning partners or TBR secretariat. And if approved, the applicants are encouraged to share their findings. We check both internal and external usage. So for the downloads of data, our alliance partners are the primary users. And regarding general public, we have processed 71 individual research projects, as well as 28 commission work projects. And for our API service, we also process over 41,000 requests. So that demonstrates our sensitive release workflow is not only functional, but actively used. So in summary, we have made 4 key achievements. We established a national alliance and launched one-stop portal, which integrated more than 29 million records. And we developed biodiversity data standard and implemented a sensitive data release workflow. For the next steps, we want to actively promote and continuously improve the biodiversity data standards and facilitate reporting the new names to enrich Taiko. And we are also working on established workflow for publishing data to GBIF. Okay, so that's my talk.
Thank you. Because of the time and
Yeah.
sorry for the technical issue. he is research on biodiversity, and he is from National Museum of Science. So, yeah. And should we have like one question for Jin-Ying? Sorry. Make it like more flexible. Does anyone has question for Jin-Ying? Yeah, please. The presenter is now online, ready for the okay. We will play the video.
Hello everyone. I'm sorry about the technical problem. My name is Showtaro from Museum of Nature and Science, Japan, and it is very honor to speak here today. I'm very sorry I cannot meet you in person in this wonderful city of Kokoda. And I'd like to sincerely thank to Marisa and Taiwan and our all organizers for arranging this excellent session. Today I will give a talk entitled The Recent Trend of the Biodiversity Information in Japan. First of all, do you know where Japan is? Japan is the island country.
archives. In recent year, Japanese Museum Act was revised, and it now clearly states the importance of open archive museum materials. So as I mentioned, the Science Museum Net plays a key role to the process, such a process. It means the open science and digital archives. And Japan Science Museum Net published to the not only to the GBIF but also the Japan Search, this website, and it is a Japanese version of Europeana, and Japan Search is operated by the National Diet Library, and it aggregated various type of metadata from across Japan, and it enabled to cross-disciplinary researches that connect museums, libraries, many archives, and research institutions. The importance of archiving specimen images is also increasing. So in our museum, we publish the images from our type specimen database, and some also we publish the special digital collection using a IIIF format, IIIF image format. The IIIF is now a global standard for sharing images and for in the digital archives field, and it allows the user to view and compare and annotated images from different institutions in one viewer. And this technology promotes how to say operationability among the digital archives. And Japan Search is also fit to the such kind of IIIF technology. And finally, I talk about the taxonomic checklist. This checklist are important for two reasons. One reason is to sharing the Japan taxonomic knowledge from Japan to widely, and second is sharing the Japanese very a kind of vernacular name, but Japanese standard Japanese name, or sometimes the synonym of the Japanese name to the GBIF. So Japanese people, Japanese person, or other foreign person can search or use the Japanese name in GBIF. The last year we start publishing the national checklist, and the first list is penguin list, and it include the scientific name and many Japanese name of the fan, and that this name is widely used in Japanese researcher and amateur scientists in Japan. And as a result, after we published this data, this checklist, our Japanese vernacular name are now included to the GBIF backbone taxonomy, and we can use this name from the GBIF website. Sorry, to summarize my talk, before summarize my talk, recently Japanese government is now strongly promoting the collection of use biodiversity information, and the strategy of Ministry of Environment clearly mentioned that GBIF is a key element for the future plan. And it is my summary. Regarding the specimen information, we are promoting the open science by supporting the database publication through the GBIF and Science Museum Net to the GBIF. And regarding the digital archives, we are working to publish the richer data information, specimen information, including IIIF image technology, IIIF images. Additionally, the Japanese government is now working on the archiving and publishing information through Japan Search. And finally, about the taxonomic checklist, publication now began, and we have a plan to publish the future plan about many taxonomic group like fishes and plants or something. Many specimen, many taxonomic group. So I'm sorry about that. Really confusing about the technical problem, but thank you very much for your time. And if you have any question, please please send me an email or something like that. So thank you very much.
banana. Okay, so spatial changes caused by climate change is a threat to global species diversity. While our knowledge of existing species on Earth is fairly debatable, insects are the most diverse organisms, forming 50% of all species. Changes in their spatial distribution can impact human health and food security. For India, an already increased average temperature and anticipated climate change can impact insect diversity. India hosts more than 67,000 insect species and is adding nearly 400 species per year to the list. The widely applied species distribution modeling techniques estimate these changes based on species occurrences and environmental factors to indicate species vulnerabilities to climate change. So, analysis of regional modeling studies may reveal their global alignments to indicate local management strategies. Therefore, in this study, we reviewed STM researchers on that have utilized insect occurrences from India. We searched Web of Science and Scopus databases and selected 118 papers for the final analysis. So here is the graph for the selected papers, and it shows that there is a cumulative rise starting from year 2008 till 2024, and there is a noticeable increase from 2017 onwards. We next analyze the scope of these studies. So we categorize them into global, regional, national, and subnational level. So in the context of India, the studies were lowest at the national and subnational level, and most of the studies were conducted at the global level. We also analyzed the corresponding author countries for these studies. So beyond national level, China was the main contributor to these studies. And next, for the species occurrence data sources, so literature was the most used data sources in all of these studies, followed by GBIF. And as visible at the country level, they are mostly using field data for their SDM researches. We also analyze the SDM species groups, and we found 10 orders that these species have modeled, mainly 5 orders per model. These are from Coleoptera, Diptera, Hemiptera, Hymenoptera, and Lepidoptera. The most studied was Hemiptera, having the highest species, highest genera per study. And we next looked at the genera with highest number of study. So here, the image first one on your right is of genus Bactrocera. So they are fruit flies, and they are agricultural pests. The second one was Spodoptera. They are fall omnivores. They are also agricultural pests. So they had the highest number of studies. They were followed by the studies on Aedes mosquito for their role as disease vector. So we next looked at the projections, models, and predictors. So most of the studies model the current climatic distribution, and past climate distribution studies of Veritas. Most used model was Maxent. It's a machine learning model. There was a mechanistic model, Climax, which was also found to be used in these studies. And in the predictors, climatic data consisting of temperature and precipitation values was used in all of these studies, and it was followed by topographic variables in some 27% of the study. We also analyzed the applied areas for these studies. So the 5 main insect groups are shown here. So invasion was a common area in all the groups, and they were well overlapped with the agricultural and forestry area. So mainly pest invasion was a common area that was being mainly studied through these SDM researchers. In human health, area studies were mainly from Diptera and Hymenoptera, Diptera for mosquitoes and Hymenoptera for fire ants. And in conservation areas, studies were mainly directed towards the bees for their role as pollinators. So in conclusion, there was vast scope to study insect diversity through SDM, considering the number of described species for India. And coverage across insect functional role may prove socio-economic relevance of SDM, considering the rising vector diseases and decline in beneficial insects. And use of diverse data sources and studies can promote better data publishing practices and higher data generation, higher data application in SDMs. They promote higher data generation for species that are considered globally. That's all from me.
Thanks for Mamta's presentation. And the next one is Ashwin from WWF India, and this presentation is in video. Okay, and the topic is harnessing citizen science for urban biodiversity. Insights from the Hyderabad annual tree biodiversity survey.
Hi there. So today I want to show you or bring your attention to a very interesting citizen science event that happened in a city called Hyderabad from the state Telangana, India. So this is known as the Hyderabad Annual Tree Biodiversity Survey that was conducted in 2025, and this is an insight into it. So why is this survey and what was the idea behind it? So in today's urban context, we see that the urban green infrastructure is actually lacking, right? So we need a very good sustainable city plan at this modern scenario. So this is where we see that there is a huge knowledge gap between what the flora that's there and the fauna that's available, and how are they interacting, and how is the ecology working in around it. Especially such kind of knowledge is very important when it comes to developing or with respect to cities that are growing really rapidly, like the Hyderabad that we have here. So these are some of our core research objectives that we had found out, and we wanted to kind of find it out. So we wanted to find out the species richness, the abundance, the distribution of the trees, what type of trees, are they native or introduced, or where are they found, like avenue trees or the normal trees, the fauna diversity, indices, richness. These were like some certain questions that we had in our mind, and this was the way that we conducted to get an idea into it. So this was our methodology. So we did the survey on March of 9th of March 2025 in Hyderabad, and we had almost 150 individuals being divided into teams who went and conducted the survey. They approached their photograph and answer list. They had the standardized digital forms that they uploaded so that we can get real time geotagged or location specific photographs. So we had two kinds of matrices that we have followed. So the theory matrices we the entire Hyderabad region as the region. So the matrices that we had followed were primarily the species idea of that specific tree, the diameter of the breast height, the phenological state of that tree was also recorded, and these are the total matrices that we had followed. For the fauna matrices, we observed the species and the number of species that were there, and how are they interacting, and all those kinds of questions. Observations were noted down. Now this data set was downloaded, and even Analysis API and various other databases were analyzed and data was extracted. Statistical analysis was also done to determine which are the questions we had, and we were aiming to find the answers to it. This was the map of the Hyderabad that we had worked upon. So in summary, we almost documented 800 tree species in the entire region, with 108 species, out of which Pentapur zero carbon, the copper pot tree was most dominant. And we went to the biodiversity analysis as well. We saw that almost 45% of the entire augmented trees were native, which was actually a good news for us. And 42% of them being naturalized species. So this 1:1 species that you can see, the 1:1 species that you can see here is something that we call as an ecosystem gap, and which is actually showing that the city is not being optimized. So these are the top 10 tree species that we found in the, so you can see that filter from zero carbon was the most at 38%, and the rest accordingly. So this is the composition. As I mentioned, 30% of the entire species were introduced, which is actually a little bit concerning, but then on the other half, we can see that there is a very huge, good chunk of groups that are native to Telangana as well as native to India. 1:1 ratio. So this was the key. This is how we identified some key species and how Fauna Association is highlighting them. So it's not that the loading stage here, the Showtaro tree actually posted the highest number of animals and following by other animals and other trees as well. So this was the total fauna abundance. As you can see, we saw that almost thousands of animals. Okay, thousands basically on this tree. So this was some analysis that was done. This was based on number of trees as well. So we are taking the mean fauna abundance, and you can again see that Gulmohar basically posts a good number of diversity as well. So these are some analysis that were done as part of it. We checked the influence of urban settings as well. We found out that almost 82% of the entire trees that we covered were avenue trees, and the rest were tiny of them were the non-avenue trees. It actually means that the entire biodiversity that's there in the city is actually influenced from the avenue trees. So these avenue trees are going to influence the diversity that's out there, and managing them is going to be the key. There are some photographs of the event, happy smiley faces doing the service. These are some of the references, and this was conducted by WWF and other corporate partners. We collaborated with a lot of organizations and a lot of people who work with us. So we are now like to and hope that this kind of tree urban surveys happen in various other cities in various other parts of the world as well. So with that, thank you. If you have any questions, feel free to ping me or put an email. That's all. Thank you.
Ashwin's presentation, and here we come to the final presentation. It's Geetha from Nature Conservation Foundation India. Her presentation is also a video, and her topic is Disseminating Citizen Science Data in India, a case study of SeasonWatch and GBIF.
Hi, I'm Geetha Ramaswami. Hi, I'm Geetha Ramaswami, and I'll be talking about disseminating citizen science data using the case study of SeasonWatch and GBIF. Climate change is affecting the way biodiversity is responding to the environment, especially trees are changing their seasonality of leafing, flowering, and fruiting. In the tropics, this information is limited, and SeasonWatch was established in the year 2011 with the aim of understanding how tropical tree species are responding to the changing climate. It's fairly simple for citizen scientists to start participating in SeasonWatch. They're expected to go outdoors, identify one or more trees that they can monitor, and every week upload information on the quantity of leaf, flower, and fruit on these trees using either a web portal or Android app. Once the data come into Citizen Science Portal, it follows the usual data cycle of ensuring data quality, curation, and dissemination. We ensure data quality by training our citizen scientists very well in multiple Indian languages so that the standardized protocol is followed no matter where from India people are participating. And the data are then put through an automated verification system where potentially erroneous observations are flagged for further. The reviewed data are then curated for end users, typically researchers, who will require information such as species ID and their seasonality and their location. The data are available to contributors directly on their profiles on the website, but these data are also available upon request. However, there is scope of sharing this data with a much larger end user population. For this purpose, we decided to convert the SeasonWatch phenology data into the GBIF format so that it can be uploaded online. For this, we acquired consent from existing citizen scientist users and then converted the SeasonWatch data into the standard Darwin code format with the occurrence and measurement of fact extensions. The occurrence extension gives the location and date of observation, while the measurement of fact extension gives the phenology or the seasonality information. This information is uploaded on GBIF annually, and since last year, we have been able to upload nearly 60 to 70% of our data, depending on the consent given by our citizen scientists. Since its upload last year, the SeasonWatch dataset has been the second largest dataset from India, second only to the eBird dataset, and it has already been cited more than 90 times. Typically, again, the queries are for species or for specific locations and geographies. Apart from the raw data uploaded onto GBIF, SeasonWatch also provides summaries of seasonality data for select species across India, displaying it across a map and over time so that end users can easily grasp the seasonality patterns of select species. In the South Indian state of Kerala, where we received the most amount of observations from, we have also been able to correlate the flowering and fruiting patterns of the three most observed species in the state with environmental factors such as temperature and precipitation. We have found strong signals of these environmental factors on the flowering and fruiting patterns for these trees with the potential consequences for future response to climate change. I would like to conclude by saying that the upload of the SeasonWatch dataset onto the GBIF platform has tremendously increased its research scope. I would like to end by thanking our partners and our friends. Thank you.
Okay, now it's Q&A session time. And for all session of the presenters, does anyone have questions?
Yeah, so I'm curious about, you show a lot of different attributions to the.
It's just for translation, not for my.
Sorry. No, I was curious, and maybe this is more a question for GBIF, but sometimes for facilitating the use of data, we need like better ways of searching for the data. So let's say, for example, sensitive species. Is there a way, or are you thinking in a way to use the data portal to try to find like those things? Or, these phenology data sets, or population things, like there are some other variables that are needed to research, like which data sources have this type of data in them. And I think that might facilitate the use of many of these data sets.
I'm happy that you did. Maybe. At the beginning, I answered this question when you agree with the secretariat. I would communicate about the mathematics team. Sorry, it's the microphone. It's for translation. Yeah. Okay. So I work in the community capacity and not in the mathematics team. So I'm probably not the best person to address the details here, but yeah, I think the informatics team is regularly looking at the way that we can filter data in the GBIF portal to try and improve, accessibility and reuse. I think that this area of data set tagging is something that's also being explored by our data product team. So in addition to being able to filter out,
fields that are shared through Darwin Core, and then other ways in which we tag data sets that have specific functions. So, things like, are they coming from the private sector? Are there other ways of, other kind of uses that might be reasons we would want to cluster a bunch of data sets as a user that might be different to filters in the actual set parameters. So yes, I think there is scope for us to go on working on this. I'm not sure if any of my other GBIF colleagues have more insights here. Yeah, but actually, maybe I can then also ask a question once I've got the. I was interested in, I think, from TDWG, you shared you've been working on the data standards and also on the translation of Darwin Core. And I just wondered how that work was getting integrated back into patent processes. Is that something that you are, because I think with this local level information, you make the case very strongly how it's very important to have that localization of the process to make it more useful for individuals, user communities, but then also I think it would be great to connect that back in. And I know there's a session I think on Friday about translation of Darwin Core, and I just wanted you to maybe share a bit about that.
Okay, I think this question goes to me. Yeah, because I'm also like in charge of my task. We train translators, like the training workshop, and also like they will need to be going through the assessment to become the translators. So after we have translated that into traditional Chinese, and now we just add them into the Prowling project from the technique. So it's going on the process, but still because there's so many vocabularies and so many documents to translate. So it will take time to do that, but we're going on with this project process. Yeah. Jerome, you want to add some?
So I would just like to address a bit about that, because I think there's two parts going on in localizing standards, especially for course. One part is the direct translation. The other part is Jin-Ying did mention we have our own national biodiversity data standard. We discussed with the previous Chie-Jen, that the previous Chie-Jen is very weird.
They're all work for Taiwan before, so that now.
So there's this discussion there's already Darwin Core, why do we use the national data? Very similar. But I think one part is still the Darwin Core is a huge knowledge and technical barrier. So usually for people we are not already very into informatics. So for a lot of people, a lot of institutes looking at the standards, the first idea is to be good for the because that's too much. So one part we built our first national standard is to actually subset the most critical standards that are mostly used. And then the translation goes into the current most important usage. How do we see these tools? Actually, our core standard, at least in our experience, we have a lot of way to really describe it. So to give it a very concise term in our language, describing what that term actually means is challenging. The first, we are going through our second version of our national standards. So the first one is actually more easy. We only focus on simple occurrence things. And then in the second part, we are starting to think about specimen data, camera truck data, and those data used for the ecological check. And then things got very much complicated more. So we have to discuss about all these different stakeholders. How do we look at the same translation? Do we see it as the same thing in our mind? And then in that way, so then we can't really go to all. power and core. So that's the thing I said is there's two things going on. So one part is like translating all, but the national standard is actually where we work really hard on. And sometimes when the national data standards have another kind of translation, we will go back to stuff, and then we'll go back to revise those kind of.
One more to say that not every language can complete 100 completed, like translated to another language. Sometimes the term is really hard to translate. And if we translate from like Google translation to the basic one, people might not understand what it is. So it takes time to discuss and revise. Okay. And maybe so it was yeah.
Yeah, thank you. Christoph Häuser from the Berlin Museum of Natural History, German GBIF. First, thank you very much for this interesting, in many ways promising session. My question also goes to a little bit on languages and to the Thai team. I understand from a brief presentation that common names are an important feature for the attractivity of your local national forum. And I believe that's shared in many countries. However, at least in Europe, we also have some more or less serious issues with common names, other than perhaps in English. And it's twofold. First, for many organisms in many languages, there are just no common names, other than for birds and mammals and flowering plants. And in the case of Germany, for example, this has led to the invention of German common names, which then led to disputes about linguists and scientists. And the other, also perhaps better known issue is that throughout the same language area, you sometimes have different common names in the same language. So between, I don't know, north and south of the country or. So my question to you is, and forgive my ignorance about Mandarin, do you have these same issues, and how do you deal with them? Or is there, so to say, a single Mandarin common name for many species and its knowledge?
Next question goes to Jean or Sue or okay, then. Jerome.
We have a whole lot of different names for Mandarin names for things. Really interesting. We actually call it common name for a crab. It was called a crab running very fast. Anyway, so I think that's I don't think that's an easy issue. And for a very practical perspective, is that especially for species that don't have common names. In our experience, at least in my experience in TDO, we focus on the species that are really being used. Are still mostly species and over species that newly emerged into the conservation issues. And those are the ones that we will focus more on making common names being directed to the same setting. We do that through our capital by Taiwan. We also have our national but to be honest, I don't think we have a single answer. We only have tried to set up different priorities. We also have a lot of original indigenous people in Taiwan. There like a lot of different groups. And there's also a large interest in like making names and cultures. Yeah, we don't have this advanced. We hope that will be would be interesting for some other researchers that would want to develop that.
So in India, for certain groups like butterflies, what we have done is, again, India has a complex issue of 21 nationally recognized languages and so many more. So what we have done is the statewide committees now being formed to actually standardize common names for certain groups like butterflies, which are becoming really popular in citizen science these days. So those committees typically meet over 6 to 8 months and discuss species by species, what's the best suitable common name. Also looking at a little bit of taxonomy of, okay, so this whole group needs to be called in a particular way. You can't have like one species of that genus, a totally different name, and so following all those standards, and we're coming up with those names, and being published as a standardized document so that different data sets then can pick them up and be popular.
Okay, we have one last question from Urban. It's the microphone. Yeah.
So picking up from the lessons, from Japan, Taiwan, India, and because we have GBIF folks, colleagues in the room, the question is, would you want to, again, after our discussion on very establishment of national GBIFs. I mean, what are the positives and establishing national GBIFs or regional GBIFs or regional groups? That's one, because we have seen we have seen the emergence of national or in-country, for instance, from IUCN assessments, there's in-country assessing their species. First, following the world, there's no, we're seeing a trend to push for having in-country experts to assess their community species. So,
Sorry, but then if you're not present, you're the best person.
Thank you very much for the question. So I've been looking at GBIF. My role is always to be informed but GBIF is so then each country that was GBIF signing our memorandum of understanding actually also agreed to establish national zone. So we've focused a lot on national nodes as a key mechanism to reach between local, national context and context. I think slide there, you showed that very nicely, the benefits of having both local development, network standards and infrastructure, and then feeding that back to local national systems enable more customized solutions for specific needs that are very different country by country. The regional level is another key level for GBIF, and so we started, I think, already in, I think, 2008 to have regional, sub-regional cities within the nodes. The nodes can be GBIF is a committee of all the participants, and then we recognize that it's sometimes complicated to have everything going global to national, and it's really helpful to do this this regional level in between. So we have these regional committees. There are 6 of them. Asia is one as a region set up. And then those regions are meeting every other year to talk about regional priorities and to build collaboration. And we see that there are a lot of synergies that happen on the regional level, but are also very important and complementary to the national and global level. We also have our other associated nodes, which at the organizations with an international scope to sign the MOU and then also become critical members of GBIF and also establish a node. And one of the things we've been working on with the node committee this year is to clarify the guidance material. So what does it mean to be a node of, for example, a regional biodiversity in Asia, or whether it's the ISMOD, another regional body, in Asia, and how can organizations like HG and ISMOD help us also reach out and get more national engagement and more regional engagement and more global engagement. So we are trying to sort of use this mechanism in parallel, but for sure, I think that the national level remains very fundamental to GBIF because stuff is needs to link to national.
I may just to add from the executive level, being visit from the beginning, just to support what Vinyana said. I think there are only gains, and there is an obligation, of course, to have a national node and to develop that into a national portal is, as seen today, really beneficial in terms of reaching out or responding to rural local needs and interests. The only disadvantage is costs.
I can talk about it.
Like, thanks for staying up with us, and it's about to wrap up the session, and the conversation can still going on during the coffee break. So before that, let's have something together. Okay. Oh, yeah, that's okay. 3, 2, let's okay. It's 3, 2, 1. Cheese, chicken, everything. Thank you.
Max member